Start the recording. Okay, so chapter 8, question 10. Question 10. The manager of a local monopoly estimates the elasticity of demand for a product is -3. The firm's marginal cost is equal to $20 per unit. And then we're asked to express the marginal revenue. And we are also asked what's the profit maximizing price. So probably a little bit difficult on first blush. We really just have to use one of our kind of hacks in terms of we're told that given the price and given the elasticity, the marginal revenue for a monopoly obeys a certain kind of rule, right? So we're going to go back in our text to where's this rule? Here we go. So it's on page 246. We've got the monopolist marginal revenue is given by the formula. So the price times 1 plus the elasticity divided by the elasticity. So putting this into practice, since the elasticity of demand is -4, right? We're told that in the question. So this is, oh, sorry, -3. Thank you. So this is page 265. So this is chapter 8, page 265, number 10 in that first section. That's the conceptual and computational questions. So this is saying manager of the local monopoly says the elasticity is equal to -3 and the price is equal to $20 per unit. Okay, so we have that formula. The marginal revenue of a monopolist is equal to the price times 1 plus the elasticity divided by the elasticity. And so this is going to be 20, 1 minus 3 over -3. That ends up giving us 20 times 2/3. So this is the marginal revenue at 20. But we're asked for just the marginal revenue in general. And so we would just substitute out that 20 for E. So just be 2/3 times E. And so then we're asked, since the monopolist maximizes profits where marginal revenue equals marginal cost, so this is A. What's the profit maximizing price? Well, it doesn't matter if it's a monopolist, monopolistic competition, perfect competition, right? We're going to be setting marginal revenue equal to marginal cost and then solve for either Q or P. Usually we solve for Q. If there's no Q, then solve for P. So we've got the marginal cost, right? We're given the marginal cost in terms of it's constant at $20 per unit. Oh, sorry. Should never have been 20. That was never 20. All right, so we're given the marginal cost. That's $20 per unit flat. And we're to set that equal to the marginal revenue, 2/3 times P. And then we're just going to solve for P, right? So we're going to multiply both sides by 3/2. And cancel it out. We end up with 30. So that is the P star, the profit maximizing price for the monopolist. questions on that? So it's just a matter of using that formula on page 246. So this formula up here is page 246. All right, any other questions on 8? We'll move on to 9. 9 is a long chapter. It has 3 distinct types of oligopoly models to be discussed. It's going to take us at least today, probably also Monday and Tuesday. Or sorry, Monday and Wednesday. Hopefully just today. All right. So, best thing to do is always just to jump into some questions, right? That's like here. So, get right to it. We're going to start on page 295. This is chapter 9, 5. This is question. So we're told the graph that accompanies this illustrates 2 demand curves for a firm operating in a differentiated product oligopoly. So initially, the firm charges a price of $60, reduced to 10 out. One of the demand curves is relevant when rivals match the firm's price changes, and the other demand curve is relevant when rivals do not match. So which demand curve is relevant when rivals don't match any price? Where are we starting out? We are starting out price of 60 and quantity of 10. Right? So what is it saying? It's saying one demand curve is relevant when rivals match the firm's price change, and the other is relevant when rivals don't match. Christian, which demand curve do you think is relevant when the rivals match any price changes? They match the price changes. Why demand curve? It's actually going to be the steeper curve. It's going to be demand curve 2, right? So what are some of the assumptions that we have at the beginning of this chapter with regards to specifically a squeezy oligopoly? So this was a person, right? A game theory economist, Sweezy. He did a lot of really great stuff. But one of the main first things that he did, the seminal things in terms of game theory, was defining these oligopolies and their reaction functions, right? So he says the squeezy oligopoly is characterized by few firms. They produce differentiated products, barriers to entry increase, but the 3 is really the main one, right? That's the each firm believes the rivals will cut their prices in response to a price reduction, but will not raise their price in response to a price increase, right? So let's go back and look at our curve in chapter, or our demand curves in chapter 9, question 1. So, which demand curve is relevant when rivals will match any price change? So we're told in point 3 that they're going to match price decreases, correct? So if we start out at this point and they're going to be matching the price decreases, then does it make sense that my demand curve is going to be steeper or flatter? Steeper, absolutely. So it's going to be, so when others are matching my demand curve, then that means that it's steeper, right? In terms of the reaction that I get in terms of a percentage quantity change for any price decrease is greater than over here. Right here, I'm gonna, I can decrease by 1, and I'm going to have I'm going to increase in demand. When I decrease my price by 1 on D1 is significant, right? If I go just by 10. So if I go from 60 to 50 units, I'm going to go from producing 10 to 19, right? But if I'm on the steeper curve and I try and decrease by that same 10 units, right? Then I end up going from 10 units sold to 12 and a half, right? And that, depending on where I am in terms of my demand curve, that may actually decrease my total revenue, okay? Or it might stay the same. So I might be at my unitary elasticity point, and any change in my demand on this demand curve has no impact on my profit, my total revenue, sorry. Cost isn't included. So now we're asked, questions on that? Sorry. Okay, so now we're asked, what demand curve is relevant when rivals will not match any price change? So now, Christian, which one? Demand curve 1, exactly. So, right, so we're told in that third bullet point, page 273, third bullet point, they will not raise their prices in response to a price increase. Not raise their prices in response to a price increase. So if I raise my price, I'm going to lose a significant amount of sales, right? If I raise my price all the way to 70, I'm no longer going to sell anything. Why is that? Because my rivals are not matching my price increase. So, it's differentiated, but it's not differentiated that much. It's the difference between Hanes socks and Walmart brand socks and, whatever other kind of just generic athletic socks, right? So if you increase the price too much, everyone's going to ditch your socks and just go for the other socks that, are around the same price as what the price is, right? So they're on this demand curve rather than this one, which, that same increase from $60 to $70 only results in a loss of 3 units, right? I would still be selling 7,000 socks or whatever. Okay, so it's going to be what we call the lower envelope of these two demand curves. And so we end up with a kinked demand curve, which gives rise to terrible puns. So C, suppose a manager believes that rivals will match price cuts but not match price increases. There's more of this. Number 1, what price will the firm be able to charge if it produces 20 units? So 20 units. So producing 20 units means that we're on demand curve 2. We're all the way over here. And so we're going to be charging $20, right? So our total revenue would be $400 on the toast. Does that make sense? And that would just be this rectangle here between 0, 0, 0, 20, 20, 20, 20. How many units will a firm sell if it charges a price of 70? Price of 70. So we're at 70. Price of 70. And we already talked about that. We're going to get 0 units, right? Our socks are too expensive. And then we're asked, for what range of marginal costs will the firm continue to charge a price of $60? What range of marginal costs? So in order to really figure that out, we need to kind of sketch in our marginal revenue curves, right? Marginal revenue is going to start out at the same point, and it's going to yes. Sure. And so any marginal cost between any kind of marginal cost curve that's between 20 and 50 will be producing this particular demand key. So that's going to maximize it. So it's anywhere in this range. Where that discontinuity is between the marginal revenue curve. Questions on that one? So the demand or the marginal revenue curve always has twice the slope of the demand curve. And so they always start at the same price. They don't start at that. They always start at the same. So eventually, if this has a slope, slope of one, wall of one, rise. Rise of one, so it does. Makes sense. It's a very shallow curve. And so the slope of this marginal revenue curve is going to be 2 times this. So the slope here is 2 times negative 1/9. So that ends up being negative 2/9. So in the same 9 units, it's going to go down to 20, right? And so if we go from 70 down 2, we get to 50. But that, and we're at 9, and the actual equilibrium's at 10. So I'm guessing they're just around because you're graphing it, and it doesn't, But yeah, technically it would be, this would be where it's at 50, and so this would be probably what, another negative 2/9 of a percent, so that's negative 0.222. So it would be anywhere from to 48.88 instead of 50. But on the test or whatever, especially graphical ones, there's sufficient margin of error. If there isn't, email me. I will give you credit for it, and I can even change it for future. I can adjust how much wiggle room they get in terms of decimal places or single digits or tens of digits or fives or something like that. Right? So just let me know. So the second point. So now, what's going on with the demand curve here? What's our marginal revenue? So the next one at 10 gives us 55. why does it jump? Right. No, this has to do with the slope of this demand curve. Where this starts has to do with the slope of this demand curve. And same thing, the slope of this marginal revenue curve is always going to be 2 times the slope of this demand curve, right? So really, I should redraw this so that it has a steeper slope to reflect that. But as to why we're starting at this 20 figure, let me get back to you guys on that on Wednesday with a more inclusive, comprehensive explanation. So why does MR2 start here? I apologize. Slips my mind. Yeah, it was the other one. There's no 20s mentioned here. Well, right. Yeah, come.
So say you were doing this rise over and run. So then see like this one is kind of like green.
Oh.
So then you can never pick up this side for me. So green. So it's there because we're like reflecting the pink this rise.
I'm uncertain. That doesn't jive with my intuition right off the bat. I mean, the reason why the marginal revenue decreases so much is because, essentially when you have a significant decrease. Oh, so you jump to this demand curve, right? You're no longer on this one. And by decreasing the price so this is the tricky part, by decreasing the price from 60 to 50, you then go from, what were you making before? 60 times 10, you were making $600, right? And now you're making 19 times 50. What's that? What is it? 900? 950. And over here we were making, what is that? 600. So how are we making more money over here? So, well, it's not profit over here, though, right? Oh, we can't actually get over here. This doesn't really exist, right? We get kicked off of this one, and we get tossed onto. No, that's not right. That's the one that exists. Oh, I'm getting so confused. No, this is the lower envelope. This one doesn't really exist. Same thing with this one, right? These two are just kind of artifacts that are not really important in the same way that this is. And so we're never going to get over to this point. And in fact, if we decrease the price from 60 to 50, then we end up right over here. And we end up with that 12.5 amount, right? And so what's 12.5 times 50? That's going to be 575, right? So we go from making 600 to 575, right? Because we can't actually get to that D1 to the right, or actually it's more appropriate to say we can't get to D1 below this equilibrium price, below this pink price. So if we try to go below $60, we get kicked off D1 and we go to D2, and we end up actually decreasing the total revenue from 600 to 575. So the marginal revenue, when we go from making 10 units to 11 units, right? And then we can actually calculate it. So this is 10, this is 11. It's going to be 10 times 60, so it's 600. It's going to be 11 times, what are we going to say this is, 58? Or sorry, we're not on that curve. We're on this curve, 55, right? So that's 55. Right in the middle. Again, rounding's fine. So at 11, it's 55. So our total revenue is equal to 11 times 55, right? Which ends up giving us 605. Awesome. So what is the marginal? Is that right? 605? So then our marginal revenue is actually 5 instead of 20. All right, we'll get back to this. How did they get this 20 number? I will get back to you guys on Wednesday first. All right, moving on. We're not making any progress there. Question 2. Aha, here's one I know the answers and the explanations for. So let's jump into this one. So question 2. So I'm gonna make a note here, right, to get back to question C3, right, about the range of marginal cost where they will still charge the price of 60. Stay tuned for more on Wednesday. All right, now let's jump to same thing, chapter 9, 285, question number 2. All right, so we are told in questions number 2, the inverse market demand for a homogeneous product for no duopoly is the price equal to 200 minus 3 times Q1 plus Q2. And the costs are given by the cost for the first company is 26 times Q constant cost. Cost for the second company is 32 times Q constant cost. The first thing we're asked to do, and it's going to take us a bit, is to determine the reaction function of each input. So what is this talking about? The reaction function of each input. So what's the first thing that we need to do? So if we want to actually go through like the derivation of this, right? Of course, there's an algebraic shortcut that the book gives that'll go through after we do the fun stuff. But what's the first thing that we have to do in order to figure out these reaction functions? What do we always do in order to maximize profits? Any company. I hear whispers. Solve for quantity or something. I mean, how? What are you going to do? Just put price equal to cost? What is what we do always? Set just those, set 200 equal to 3, Q1 plus Q2 equal to 0? So what do we usually do? We have price, and we end up building that into the total revenue, and then we build a profit function, right? And then we take the derivative of it, set it equal to 0, get the maximum, and then we solve for one of the Q's. So here's an issue though, is that we're not, it's going to be like Q quantity 1 in terms of quantity 2. Okay, so it's kind of difficult, right? Because again, at the end of the day, the price is determined not only by what I do as Q1, but also what my other person in the oligopolist industry, my rival, is doing, right? So, and this is, public information. They know my costs are lower than theirs, and we're trying to figure out what each other's going to do. Okay, so let's go ahead and get started. So we've got a Cournot duopoly with the price is equal to 200 minus 3 times Q1 plus Q2. What's going on back there? That's equal to 26 Q1. That's equal to 32 Q2. All right, so what's our total revenue? Our total revenue, probably the easiest one, we just take price times quantity, right? Oh, sorry, here, I'm gonna get rid of this since we got all the information. What? Oh, over. Okay, and so this is going to be 200 Q, okay, so this is total revenue 1, right? So this is all Q1. 200 Q1 minus 3 Q1 squared minus 3 Q1 Q2. Questions on how I got from this to this, from 1 to 2. I'm gonna make it more blurry so you remember. Come on, what are you doing, man? Killing me. All right. You guys get it? Do you want me to unpack it? Okay. Light blue. So in between here, we've got 200 minus 3 Q1 plus Q2 times Q1. So then the Q1 is going to go initially just 2 places, right? It's going to go to the 200, and then it's going to go to this ugly term, right? So then we're going to get 200 Q1 minus 3 Q1 plus Q2 times Q1. Everybody with me there? Yep, awesome. So then we're going to take this Q1, and we're going to multiply it by the Q1 and by the Q2. All right? So we're going to get 200 Q1 minus 3 Q1 squared plus Q1 Q2. And then I'm going to take the 3 and I'm going to distribute that to the Q1 squared and the Q1 Q2. So we're going to end up with 200 Q1 minus 3 Q1 squared minus 3 Q1 Q2. That's how we get to this. Okay. Q1, it's like this is like we had x plus y times x, it would be x squared plus xy. Does that make sense now? Just think of them like that. Yeah, so since it's the total revenue for the first firm, I'm going to multiply the price equation by the quantity for the first firm. So this is the price. It's not really the price for the first firm, it's the price for everyone, right? So that's why I didn't do P1 here. So the subscripts is kind of where it gives it away. Good question, yeah. Yeah, how do I know whether to multiply it by Q or Q1 or Q2? It's essentially when you're calculating the total revenue for firm 1. So I always solve for the first reaction function first, like Q1. And then the nice thing about almost all of these, I want to say, well, I don't think for the stack will work, but we don't have to worry about that. So when we get to the more complicated ones, They're not going to be symmetrical, or like one person's going to get filled first, so that's going to make things different, right? So we'll have to solve for both of them. But right now, everything's symmetrical. Everybody goes at the same time. So essentially, these things are going to be very, very, like this is going to be exactly the same for the second one. The only thing that's different is the costs, right? So we can, like, we'll derive it this time in terms of we'll derive the marginal revenue for firm 2 as well. And then we'll set it equal to the marginal cost, and we'll solve for the Q2. But you'll see that it's exactly equivalent to what we're doing right now for the first firm. The only difference is that instead of having 26 as the C in your book, so the book just has you kind of label this as A minus B, or A plus B times this, and then this is C. So the book labels these things as C. That's the only thing that's really going to differ in terms of reaction functions. Does that make sense? And so, yeah, so usually I will save a little bit of time when I'm doing it. But like I said, because the costs are different and tricky, you know, I might make a mistake there. Better safe than sorry. Just go through all this. All right, good questions, good questions. All right, so back to these steps. So that's our total revenue equation. So I think we work best when we do our optimal rule, right? Where we're going to, so we're going to try to get, so now we're going to be looking to set marginal revenue equal to marginal cost, right? That's what we want to do. I think you guys find that easier than calculating the profit equation and setting that equal to 0. And also for this, you're going to save steps, since the marginal revenue for the first firm is going to be a mirror image of the marginal revenue for the second firm. You don't understand what that means? You will. We'll see. We're going to bring it there. Right. All right. So the marginal revenue of firm 1, also known as the partial derivative of the total revenue with respect to quantity 1, right? So don't let this scare you. All this means is that we treat quantity 2 like a constant, right? So we essentially, this is just, you know, -3, which is another constant, times this constant times Q1. So when we take the derivative of this last term, it's essentially just like taking the derivative of -3 times Q, but we have this extra little thing here, right? This extra growth on it. So instead of it being -3, it's just -3 Q2 for that last term. We'll get there. Let's do it one at a time. So this one, since it's just Q to the 1, right? We know that that just drops out, and we end up with whatever is attached to it, the constant. So it's 200. This is, we're going to use our power rule. We're going to take 2. We're going to multiply it by 3. We're going to do Q1 to the 2 minus 1, right? So I'll spell that out for you guys. 3 times 2 times Q to the 2 minus 1. And then this one is going to be -3 times Q2. So very similar to this first term in terms of when we take the derivative of something that just has power to the 1, we're just going to have this, whatever's left over is the constant. Same thing over here. Since it's a partial derivative with respect to Q1, we leave this Q2 like it's a constant, and it comes right down here. I should label this Q1. Okay, awesome. So from here, we are going to set this equal to marginal cost, right? So go ahead and simplify this real quick. This is 100 minus 6Q1 minus 3Q2. And then we're going to step 5, set marginal revenue 1 equal to marginal cost 1. And so that looks like 200 minus 6Q1 minus 3Q2 is equal to what? What is our marginal cost? So let's go up here. Our cost functions are up here. So since they're constant marginal cost, and it'll usually tell you that in the prompt, it's fairly easy. The marginal cost of 1 is equal to the partial derivative of that with respect to Q1. So this Q1 drops out. We just end up with 26, right? And again, that's part of the definition of constant marginal cost, right? So for similar reasons, marginal cost 2 is equal to 32. So irrespective of where we are in the production process, those are our marginal costs. So this is pretty easy. We get to set it equal to a constant, right? Set it equal to 26. And then we're going to solve for what? Q1, right? Because this is all about the first firm So we want to figure out what is our optimal condition in terms of what does our quantity, what is our optimal quantity that's maximizing our profit in terms of the other person's quantity, right? So let's go ahead and solve for Q1. So we're going to subtract 200 from both sides. That ends up equaling negative 174 is equal to negative 6Q1 minus 3Q2. We're going to add 3Q2 to both sides. Annihilates negative 6Q1 is equal to negative 174 plus 3Q2. Divide everything by negative 6. That ends up equaling -29 minus 1/2 Q2. And so this, we would say, is our reaction function for firm 1 in terms of Q2. Kind of a lengthy process. Let's do it again for firm 2, just to reinforce the learning. Well, we got that's 5 for it. And then we'll pick up here in class on Wednesday with how to put the reaction function together and solve for the. Oh, sorry, we'll pick up here on Monday. I don't know where I am. Look at me, I know what day it is. How'd your Friday Night Lights event go the other night? Awesome, man. That was a great idea. That was fun. Seeing that. Right. Yeah. Absolutely. Absolutely. No, that's great. Okay, so quickly now, let's do the same process for the firm 2. All right. Okay. So firm 2, it's going to be total revenue is equal to price times Q2, right? So it's going to be 200 minus 3Q1 plus Q2, all of that times Q2. So I'm not going to walk us through the steps again, but we know that we end up with 200 Q2 minus 3Q1 Q2 minus 3Q2 squared. So that is our total revenue 2. To take our marginal revenue 2, we're going to take the partial derivative of that with respect to quantity 2, right? Because it's marginal revenue 2. So this is going to be equal to 200. It's just a constant. We're going to do minus 3 times Q1 because, again, Q1 is treated as a constant, and we're taking the derivative with respect to Q2. And then this one, we're going to treat like any other x squared. It's going to be 2 times that 3, so minus 6 Q2 to the first power, right? So that's our marginal revenue curve. What are we going to do? We're going to set that equal to our marginal cost curve, right? Our marginal cost, we know, is 32 for 2. And so we're going to say 200 minus 3Q1 minus 6Q2 is equal to 32. We're going to subtract 200 from both sides. That ends up being 168 negative, equal to negative 3Q1 minus 6Q2. We're going to end up solving for what? We're going to solve for Q2, right? That's the thing that we care about here as the second term. So we're going to put plus 3Q1 plus 3Q1. To annihilate, we end up with minus 6Q2 is equal to negative 168 plus 3Q1. We're going to divide everything by negative 6. And that ends up equaling 28 minus 1/2 Q1. So this is our Q1 star or reaction function in terms of, or sorry, our Q2 star or reaction function for firm 2 in terms of Q1. All right, so we will pick up here on Monday and we will learn how to put these together, solve for quantities, and then of course we will complicate it once more, and that will be the end of chapter 9, and we will all applaud. All right, have a great weekend. Send me any questions that you have. Yeah, good job. Have fun. You set them equal to each other. Yeah, you have two functions, two unknowns, set them equal to each other. Solve for Q1, plug that in, solve for Q2, and then you can find the profits for each one. Yeah, it's pretty straightforward from there.